Important. I'll talk more about factoring and why it's called factoring next week. But today we are using the distributive property. And so I wanted to remind us what you should be very good at the distributive property now. So we are distributing 2x. Jordan, when you distribute 2x, what do you get?
2x squared to the second.
2x squared. Plus?
Plus 10x.
There you go. Very good. All right. And so reminding ourselves that we are multiplying when they have the same base, x times x, or x to the first times x to the first. What do we do to those exponents? You add them, which is how we get x squared. Okay, and then here we're going to distribute the 3xy, and when we distribute the 3xy to the 2x, what do we get?
6x.
Armando, what do you get?
6x squared y.
6x squared y, very good. And then plus, what else? Olivia, what else do we get?
We get 9xy to the second.
9xy to the second, very good. And I'm going to distribute the 4a squared b. And 12. What else? A to the third and b to the third. Very good. Minus 8. A to the third. B squared. Very good. Okay. So the a cubed came from a squared times a to the first. They have the same base, so we got to add those exponents. This is distributing. Hopefully, you're very good at that. Okay? Hopefully, that's very easy. Because today, we are doing it in reverse. We are starting here and going back to this undistributed form. Okay? So today we are undistributing or unmultiplying. What is unmultiplying also known as? Dividing. Okay? So today, instead of multiplying, now we are starting to divide. All right? And that's essentially what factoring is. I'll talk about why it's called factoring starting next week. So example 1, factor using the distributive property in reverse. Factor using the distributive property, also known as the greatest common factor. Looking for the greatest common factor. What we want to look for is we have a couple of terms here. You can see we have a 3x and a positive 9, so we have two terms. And we want to look at those two terms and ask ourselves, hey, what do they have in common? What can we divide both terms by? Yeah, so what we're doing is we're looking for the GCF, and that's just asking ourselves, what can we divide both terms by? They're both divisible by 3. So we are going to unmultiply the 3, also known as divide each term by 3. And what that does is we are unmultiplying it, we are undistributing it, and relocating it back out in front where it came from originally. Now we get to clean up this thing. What is 3 divided by 3?
X.
1x. 3 divided by 3 is a 1, and there's still an x there. And then what is positive 9 divided by 3? Positive 3. 9 divided by 3 is 3. Okay? All right. Now, that's what we're looking for. How do you know if you did it right? You multiply it. You distribute it. You check it, ladies and gentlemen. Do you have to check it? No. Can you check it? Yes. Can you check it on a test? Absolutely. Okay? If we were to check by redistributing, 3 times 1x gives you 3x. And 3 times 3 gives you positive 9. And that is what we started with. Okay? So you can check all of these by distributing. All right? Let's look at letter B. We've got numbers and letters. We want to find the GCF, greatest common factor. What number can they be divided by? 5. They can both be divided by 5. What about letters? What letters do they have in common? An X. Each term has an X. So we're going to divide out that greatest common factor so that we can relocate it out in front. It doesn't disappear. It's being relocated. That's all that's happening. What is 5 divided by 5? 1. 5 divided by 5 is a 1. And what is X divided by X? 1. X. How many times does X go into itself? 1 time, right? Okay. What's left here? Yeah, a 1y. I'm going to write 1y. Do you have to write the 1? No, you don't. What's 15 divided by 5? 3. What's X divided by X? 1. So what's left here when we divide this? Minus 3. Where did the 3 come from? 15 divided by 5. That's it. Taking out what they have in common. Yeah, that's right, you weren't. Okay. 5a cubed minus 13a squared. We want to find the greatest common factor. Is there a number we can divide both of them by? Nope, can't. We don't have a number in common that we can divide by. What about letters? A. Here's the tricky part. They each have an A. But how many could we take out? How many do they have in common? A squared in common. Very good. This one, if you're thinking about it, is A times A times A. This one is A times A. A squared is A times A. How many do they have in common? There's 2 that we can take out of each of those. Oh, does that make sense to you? Okay. So when you're looking at powers, you can always take out whatever the lowest power is. We had A cubed, we have A squared. The lowest is A squared. That's what we take out. Okay? So I am going to take out an A squared from both of these and relocate that out in front of parentheses. What's left behind when this gets cleaned up? 5a, very good. Minus 13, very good. Why? Why is it 5a minus 13? Because you're dividing by a squared. Yeah, what is a cubed divided by a squared? A to the first. How do we get a to the first? You subtract the exponents. Very good. When you're multiplying, what do you do to the exponents? You add. What do you think we do if we're dividing? Subtract the exponents. 3 minus 2 is 1. It's the opposite. Okay? All right, here the a squared divided by a squared is 1. Okay, leaving us with the 13. All right. Last one. We have 2 terms. We want to know, what do they have in common? What number can we divide both by? 4. What about letters? What can we divide both by? X and a Y. They each have an X and they each have a Y. So I'm going to divide each term by 4xy so that it relocates out in front. When I take out the 4xy, when I divide out the 4xy, what's left behind? Plus 3y. Very good. It's as simple as that, ladies and gentlemen. The 4's reduce, the y's reduce, and x squared divided by x leaves an x. 12 divided by 4 is 3. X divided by x is 1. Y squared divided by y is a y. How do you know if you did it right? You distribute. You check by distributing. Do you have to do that in your homework today? No. When are you going to check? On a test. Okay? All right, ladies and gentlemen, do you have questions for me? All right.